Well, hi, good morning. Thanks so much for joining me in my shop. We're going to be taking a look at this Philco. Really? Okay, it's just my cat in the background there. We're going to take a look at this really cool Philco roll-top radio. I had a look at this a while ago. 4 years ago, in fact. I had this on my bench. It wasn't even in this house. It was in my old house even. Took a look at this, did some preliminary work on it, very preliminary work, and determined that it's a sick puppy. This is one sick puppy of a radio. What I did was I, rather than plug it in or put batteries in it or whatever, I just hooked up a high voltage supply to the high voltage circuits in here and found that there must be a short in the radio somewhere. So time to carry on and try to bring this guy back. At first glance it looks kind of terrible, but on closer examination this is actually in really good shape. It's just very dirty. And look at this. You know what this tells me? When you look at the leather handle here, this radio was used a lot. Look at it. This was used a lot. At some point in this thing's life, this was the radio, which was going everywhere for somebody. So with that in mind, and word is, this is a really good quality radio. Let's see if we can't fix this guy up and get him working. Now I'm thinking the last time I worked on him, what probably happened was another project came up and I switched to a different project and left this one standing for 4 years, in fact. So I think this is just sitting in here. Out it comes. Speaker, a whole shooting match here. Some more interesting stuff inside the cabinet. Take a look at. This, my screws. How does this go? So this is sitting right in there. Probably going to desolder that. So leave it out now that it's out. Probably desolder that. This capacitor shoved in there, it's tied in place by this piece of wire. Literally. That can't be original. Oh my gosh, Mr. Peanut, it's so snowy outside. You know, you're in for the count. You're in for months. So look, 3-section capacitor. So what that tells you right away is that this is better than most radios for sure. This has a tuned front end on it that many radios don't have. So wow. So yeah, potentially this will be a good radio. 1, 2, 3, 4, 5, 6 tubes. So it's this big one. Maybe that's the output tube. It's a big one. Oh, some notes. I think we better read the notes here before we do anything. So here's a note here. Spin. Oh, there's a note on the back. There's notes everywhere. Let's read them all. Read them or weep. So this one says, to use external antenna, remove this lug from under the screw and attach the antenna to the lug. This is the lug here, and it's just attached right to the chassis. But that's where you put an oh, okay. There's 2 other wires. These must be the antenna leads here. Whoops, hey, over this way. So is there an internal antenna? What would that connect to? I'm going to have to take that speaker off pretty soon here. Sit there. Well, there is an internal antenna. Couple of nuts in there that were loose. Philco model 409. Can you see that on camera? Sort of. I'm reading this. And it's giving tubes. Oh, these are all 1-volt tubes. Of course. Of course they would be 1-volt tubes. 1 T4, 1 T4, 1 US, 1 RS, 1 R5 rather. Not S5. 1 U4. 11 at 117 Z3. Uh-oh. And then the 3Q5 GT. 3Q5. Never heard of it. Oh boy. We better get right into tube testing here before we go too far into this radio, because I don't have replacements for some of these. To remove the tubes, tilt in this direction of the tube socket rivets until locking spring releases. What? So there's something special about pulling the tubes out here. To remove tubes marked star, rock gently with a circular motion and pull. That's the usual way to pull a tube out. So some of these have some kind of locking thing in them. Well, they don't just look like tubes in a socket to me. I don't know. Okay, part number. Final inspection. And then here's the antenna here. And I know this is probably not too well lit here. There's the antenna terminals, capacitor, and the antenna is made from this kind of broad piece. You know what? I think there's probably a loop of wire going under this. I bet you this is just a protective surface. You know, and I can feel it. I can feel it. Great. Okay, so there's a very special antenna. Tuning this radio without this antenna connected is probably a mistake in the final stages. What's that? Qu'est-ce que c'est? What is this? You know what this is, I think? So this radio, when it's in, is actually upside down this way. So this is actually pointing down. So it would be over here pointing down. I wonder if you slide in the battery pack, you have to push this up, and then the radio is switched to batteries. And you pull out the battery pack, it flips it like that. Got no idea. Just taking wild guesses here. So there's a nameplate on here. 409 says right on it. A Formula 409. That's quite interesting. So as far as controls go, this one is completely backwards. It's on. But I think when you mount this kind of upside down with these protruding out the front of the radio, it'll appear to turn the right way. I think that's what's going on. So, wow, where do you get a potentiometer that actually turns backwards with an on-off switch? You don't. Very heavy string on here. Yeah, I think this was built for mileage. Oh, what happened there? The string is sliding through the pointer grip. So the pointer is malarkey. Its position anyway at this point. Let's pull out this unusual. Oh. I'm looking for the tube name. It says Canada. I can read Canada there. Westinghouse. Well, my guess is it is the correct tube. So this is the only octal tube in here. And that is supposed to be a 3Q5 GT. Oh my gosh. 3Q5. I wonder, when I tested this for short circuits, and I discovered there's a short circuit in here, could it be the tube itself? I think, you know, unless all these tubes are good, there's no use proceeding with this radio at all, because I'll never be able to get it to work, in particular this one. So I even have to find out if I can test this tube. I actually have my tube testing list handy here. But this is a addendum to the original list. But I wouldn't be surprised if this tube is in the addendum. Let's find out. 3Q5, right? 3Q5. So of course, after they make a tube tester, they have to send out addendums every year to cover the new tubes, or tubes they missed along the way. This addendum here, there isn't a single tube with a 3 on it. It actually covers a bunch of older tubes that they must have left off or didn't bother with initially when they marketed this tube tester, and then found out that people were still interested in the older tubes. That's not going to help us on the... Let me look at it in my tube manual here. 3Q5. 3Q5, beam power tube. There it is. May be supplied with pin number 1 omitted. Tube requires octal. Series filament for parallel. Filament considerations 3V4. That's a more common output tube. And there's all the operation stuff. So, okay. Well, we got some information on it. It's not that unusual. Well, okay, so 3Q5. It could just be in my tube tester main list. Let's take a look. 3B, 3C, D, E, F. Oop, 3Q5. There it is. 3Q5. Fantastic. So I'll be able to test that. I'm sure the rest of the tubes I'll be able to test too. And we're going to start right off with the tube test. Just really not my usual approach, but then do I even have a usual approach? Let's keep going here. Yeah, just check and make sure my tube tester is plugged in. 3Q5, so 1.5. Signal 4, 45L. I usually do the setup ahead of time before I turn on the camera. 06345, 06345, 0670, 0670, 43. But the easiest mistake I can make anyway when I'm setting these up is I start reading the wrong lines down here in the guide. I accidentally shift, especially as you get along a distance. I end up setting the machine up for a tube that doesn't exist. So there we are, F. So it gives an F warning, which means it will probably show a short on one of these test positions. X2. Okay, we're going to double check now just to be absolutely sure. 3Q5. Again, I can't read it on here, but we're going to have to gamble a little bit. 1.5, very important. 45L. 06345, 06345. And I want to blow this tube because I don't have another one. And I'm not going to get another one, so probably 43C. Very important. Okay, so 670, so it doesn't have to come up too far on the scale, just up to about here. No, this will tell the tail. Well, it's going to tell a little bit of the tail. Okay, let's try the shorts. Not sure that the tube needs to be warmed up. There we are. That's the F note warning. Pointer's not visible for you. Let's see what we do. There we are. Flies over. Around here. Fine. That's good. That is very good. That means the output tube is fine. Okay, let's check the rectifier tube too. The rectifier tube is a 117Z3, another bizarre tube. So this is a 117. Yeah, I can see the Z3 here. I don't want to rub. Yeah, 117Z3. That's what it is. Oh my gosh. So the filament takes line voltage, 117 volts. Never had a tube like that before. Yeah, this will go up there, 115 right at the top. So 117 Z3. 117. A little dark for me to see here. 117. Z3, Z4, Z6. 117 P7. There's all kinds of them. Never had one before. So 117 Z3. Okay. 115. You don't want to leave this at 115 after testing this tube. That's for sure. 17Z3. Signal not important. Bias not important. 00763. 00763. 1000. 25. Get the meter to read accurately. E, the plate connection. So on a rectifier, we got to get up above here for it to be good. 117, power's on. 117 volts. Take it. I saw the little light flash there briefly. Somebody please remind me to turn this back down when we're done this tube, or bad things may occur. Now, are there any special notes? There's no notes. There's nothing. Not a word. Rectifier and diodes. Perfect. Okay, so we know now that there aren't shorts in the two tubes that are most likely to have a short, particularly this one here, the rectifier tube. So we know the short is not coming from that. So that means all lights are green to go further with this radio. I only have one light. So the one light I have is green. Any person installing or operating this receiver without first having obtained a license from the Minister of Transport of Canada is liable on summary conviction to a fine not exceeding $25, and the said receiving set may be forfeited to His Majesty by order of the Minister for such disposition as the Minister may direct. That's pretty interesting. Just looking for more notes. I think we've read all the notes that are available here. Guarantee. Philco. Oh, your guarantee of safety. Oh, what's the guarantee of safety? It's got an arrow there. What is it talking about? Oh, it's on the speaker. Okay, now let's put this back like this and take a look at it here. Sooner or later I'm going to damage the speaker doing this. Oh, Philco is your guarantee of safety. I think that's what that actually means. Printed in Canada. Yeah, so I think that's all that means. I don't think there's an arrow pointing to what the guarantee is. Gee, I wonder if a shorted up power wire would cause the short I saw when I did that high voltage test 4 years ago. Okay, now it's time to look underneath. You can turn this guy right upside down. What would happen so bad? I'd be resting on this, which isn't. Yeah, this is a rugged radio. I can just tell it's really solid. I'm going to disconnect the speaker at this point before I do damage to something by tugging on it and that. Okay, let's desolder these wires. And, for the speaker, I'll get that out of the way. Came out awfully easy. The terminals like this, they may also have, they very likely have the wire from the transformer soldered to them, kind of mixed up with the wire I'm trying to remove. There's always a chance you're going to do something to the other wire without knowing it. Come on. There we go. It's come off pretty easy. No, they don't come off easy. Put up a fight there. Check this one. I got fooled by a speaker there a couple of radios ago. No, that looks just fine. Good. Put them over there for now. We still haven't looked underneath, have we? Okay, here it comes. Underneath. I can do it this way. Whoa! Wow. Okay. First impression. Yeah, a fair bit of stuff in this radio. But you know, these capacitors are all really easily accessible, or so it looks at this point. Wow, there's a lot of them. So let's see. There's one way up in here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 paper capacitors to go. Yeah, here's that switch, that plunger switch is here. You've got the power cord coming right to it, so I'm sure that's what that was. So you cannot plug this in with batteries inside it and have something really bad happen. Wow, there's a big pile of debris up in here. It's like a mouse house in there. Could be. Somebody was making use of the radio for a while. So as I look in this, I don't see anything here that's dramatically out of sorts in any way. So again, the green light's on. Go ahead and try to restore this guy. Wow, that capacitor's in bad shape. Ooh, is that a special shielded capacitor? Once in a while, when you see a paper capacitor and it appears to have an extra layer of paper on it, once in a while, that's because there's actually a shield, an extra shield in here with an extra wire. So you see 3 wires coming out of this, but there isn't in this case. This is just a, who knows what they were doing. Okay, yeah, nothing unusual here. Lots of capacitors. Now, question, shotgun this thing? I'm really against shotgunning. It's not my, shotgunning means to change all the parts at once. Or you know, one at a time. But basically to not try to run the radio in the interim. Just change all the capacitors and then try it. It's tempting. Well, you know, I don't have to make that decision right now. I can start changing a few, and as I go, I can decide whether I want to, you know, if I want to try to test it. You know, my suspicion is one of these has a short in it, but it's just a suspicion. Well, regardless of what the short is, if changing the capacitors eliminates the short, then the problem's solved. If not, then we'll just have to troubleshoot to find out what it is. The main things it can be that could cause me big trouble are tubes I can't replace. Check 2 of those. The other 3 tubes I can replace. I have replacements for it. So in light of the fact I haven't got much else to do these days right now, I might as well put the time into this one. So I'll hunt down the schematic for this. I'll study it up, then we'll go at it, and we'll try to do this in some kind of sensible way. And you know what? I'm thinking I'm going to try to power this thing up again, because maybe I booped it up first time when I tried. Why don't we try that right now? I mean, what have I got to lose? I got nothing to lose. So to do that, we're going to employ the same piece of equipment I did 4 years ago. That's this guy up here. So I read the comments. I have one video on this, and if you want to watch it, fine, but it'll look very much like this video, really. And it ends with me doing exactly this test. So I'm going to go on there. And this, we will connect to this terminal here. So I'm going to be basically feeding in high voltage right onto the filter capacitor in the power supply. And that should basically energize the whole radio. Trouble anywhere in there. Now from here, it's in the camera, you can barely see the needle up here, the pointer. Stand by. Volume. Voltage down. So the objective here is to apply a couple hundred volts, or 100 volts anyway, let's say 100 volts onto the radio, just as it would in its normal operation, and then read the amount of current flowing because of that voltage. The current flowing in this radio, because of that voltage, should be almost nil. Hard to see on this meter at all. Now this thing, the scale here is, that's 100 milliamps where the red line is. So, you know, if it went up a little bit and sat there, that would be okay. When I did this test before, it could not raise any voltage. It was all current, and that indicated short circuit. So here we go. Are we ready? Down. On. Okay, so watching this meter here. A totally different response this time. Okay, so I've got 200 volts on this radio. This thing didn't move one iota. So that tells me this test isn't working right. Something's going wrong here. Something definitely not working right. Let's check for B plus at the receiving end. I would really expect to see some current flow. So my meter is simply going to tell us the same thing the meter up above did. But maybe I've got cord problems. I often have lead problems. Are we ready again? Not quite. Anybody yelling at me just before I hit the switch here? Here we go. Okay, same effect, no current flow whatsoever. Look, no voltage showing up. So what am I doing wrong here? You might say, well, Jim, why don't you fix your leads? Yeah, I have fixed these leads. I've fixed these leads too many times. Let's just try it on. I have a special hook where I hang my bad leads. And when I feel up to it, I will take them all and fix them all. Actually, no, that wouldn't be wise. Let's put it right on. Make sure we get the polarity right on this. Okay, ready once again. Let's raise her up. Okay, this time it's going up. What's happening up here? So it's not a dead... What's that? thought I heard something click down here. It's just my hyper imagination at work. So what we saw there, we don't have to do anymore, is far too heavy of a current here, but not a dead short, but far too heavy of a current. Okay, let me just make sure I got this off. What could that be from? It could be from a very leaky capacitor. It could be from a bunch of so-so capacitors. It's a pretty heavy leak. Could be from most likely place, I think, is the original filter capacitor. So I think I'm going to proceed, since we're not going to hear this today, I'm going to proceed with studying up on the schematic, and then we'll start picking off these capacitors and see if we can't bring the whole radio to life at some point before I get them all changed out. Suppose I could set up a situation where, as I cut the capacitor out, if there's a change, I can see it. Couldn't you do that just with an ohm meter? He says wistfully. Why not? I think I was reading about 1,000 ohms here, based on the current and the voltage fed in here. Should be easy to read. Let's just hook this right back up. Okay, so that's on the negative. But now there's going to be potentially, a little pun there, everybody. Potentially some voltage in here. Let's see. An interesting sign. If there was some voltage, it would be hard to explain how come there's what appears to be a partial short, and yet voltage remained. So good thing there's a 0 here. So 3,800 ohms. Well, that's really interesting. Is there anything? What if I just turn these controls and do stuff? That's tuning. That shouldn't do anything. That's it. Not many controls to turn. I can't imagine poking around here is going to do anything. Okay. See my cat working away in there? That's what that is. Never complain about her scratching there, because scratch there. Leave our furniture alone, cat. You have a good scratch there? That's her special piece of wood that she likes to scratch on. Whoa, she disappeared. Well, we'll find her later today. Okay, so thanks so much for watching, and away I go on this radio.